So we are going to talk about many topics in this presentation. Okay, and again, last topic is namespaces, and we are going to review the concept that we covered, like a target namespace and source namespace and things like that. So motivation for XML schema over DTD. So XML schema provides more powerful and flexible schema language than DTD. So DTD was used as the schema language before XML schema was born, and DTD was designed mostly for publishing industry, so it does not actually provide a robust and powerful schema language. So that's the reason XML schema was born as the standard and more powerful schema language over DTD. One of the problem of DTD is that it is not an XML. Okay, DTD is not XML, the XML file. Okay, so that's one reason why we need XML schema. XML schema itself is XML, XML document. We represent XML document syntax in XML language. Okay, the advantage of having XML schema as a schema language is because the XML schema is XML. You can use XML tools for validation, for example. Okay, it supports non-textual data types like an integer. So DTD was designed for publishing industry, so it covers mostly on strings. Okay, however, it doesn't cover other data types like integer. However, if you are building an application where you want to send XML document, a lot of things in XML documents should represent different data types like integer. Like in B2B or e-commerce application, like a price should be integer data type rather than string data type, right? Okay. XML schema also handles a lot more powerful syntax. So with DTD, you cannot specify things like this. A value of an element is in the range of 10 to 100. Okay. So this kind of thing cannot be specified in DTD, so that's the reason we need more powerful schema language. Again, that's the reason XML schema was born. Now, XML schema was not part of XML 1.0. So when XML was first designed, XML schema was not part of it. Okay, so at the time DTD was used. Okay, so DTD was used at the time as the as a validation tool of your XML document. So when XML document is validated with DTD, we call it valid. When XML document is validated by XML schema, we call schema valid. But these days, nobody's using DTD anymore. So when you say valid, when XML document is valid, that means we are using XML schema as a validation. Okay, meaning XML schema is used as a syntax for that XML document instance. Now, given that DTD is rarely used these days, valid usually means schema valid. Okay, so XML document that conforms to a particular XML schema is called instance document of that schema. So you can think of XML schema that defines a syntax of XML document instances. For example, what XML schema says that the name has to have a first name and last name. Okay, and if your XML document instance just have the first name only, then that XML document instance is not a valid XML document instance against that XML schema. All right, so moving forward. So hopefully you guys have a sense of the XML schema versus XML document instance. Okay, so again, XML schema defines the syntax of XML document instances. Okay. Now let's move on. Now we are learning how to define things in XML schema. Okay, so definitions and declarations. So definition is for creating a type, and the type could be either simple type or complex type. Declaration is the usage of that defined type. So let's see example of this. So in this case, we are defining a simple type called a zip union. Okay, and don't worry about this. Basically, this is the definition of zip union simple type. Now, in order to use this type in an element, okay, so we say element and name zip is type is zip union. So this is the declaration. So in this case, we are using the type defined here. Okay, so again, we are looking at XML schema here. Okay, so in XML schema, you define a type, and then you use that type to define an element called the zips. Okay. Okay, so moving forward, schema data types. So there are two different types, simple types and complex types. So simple type definition does not have sub-element. It doesn't have element sub-elements, or it doesn't have attribute sub-element. It can be either the predefined simple type or derived from predefined simple type. Okay, so we'll see examples of this. A complex type definition, however, has sub-elements. The sub-elements could be element or attribute. It could be both. Okay, so let's see an example. Simple types. So XML schema specification comes with a set of built-in primitive simple types like a duration, date, time, time, date, and string. So these are predefined primitive simple types. It also comes with a set of derived simple types. So these derived simple types are derived from the other simple types, okay, like integer, non-positive integer, long int, and things like that. So this is an example of predefined simple types. So again, this is XML schema, okay. So you can see this is the XML schema. This is the prefix, okay, schema prefix, and here XSD. So any element that actually starts with you can think, yeah. So let me actually repeat. So we define the namespace, okay, and the prefix we use is XSD. So any element that belongs to this namespace, which includes a schema element, okay, should be prefixed with the XSD. Okay, and then any XML schema should have a target namespace. So these are the target namespace, meaning any elements you are defining. So the elements you are defining is like a title, heading, topic, price, focus. Those belong to this namespace. Okay, and then it has another the source namespace. Okay, which is prefixed with TNS. Okay, so anything that start with a TNS belongs to this namespace. Anyway, so here we defined elements like a title, heading, topic, price, and focus using simple types. Okay, so these simple types are predefined in XML schema specification, string and decimal. Okay, so it's derived. So derived simple types are derived from existing simple types. That existing simple type could be again predefined simple type in XML schema or derived simple types. Now, simple types could be restricted. Okay, so typically what we are going to say is that you can restrict existing simple type by using restriction element. So that existing type is called the base type, and basically by restricting it, you are confining the set of valid values as a legal range of values. For the new type, it's a subset of the ones of the existing type. And so you are going to use a restriction element along with face sets to restrict the range of values. Okay, so you can think of face sets as a rules of restriction. So let's see an example. So this example defines a simple type called myInteger. Okay, now we are using restriction element to restrict the possible values. So base type is XSD integer. So base type is integer, and then we are using min inclusive and max inclusive face set. So what it means is that this myInteger type is integer values that belongs to that are within the range of 10,000 and 99,999 inclusive. Okay, so just repeat what I said. Defining myInteger type whose range of values is between these two, and this min inclusive and max inclusive are facets that are applied to integer base type. Okay. This is another example of derived simple type using the restriction. So here we are defining SQU simple type, and it's restricted from base type of string, and we can use regular expression as a facet. Okay, so the pattern in this case is a facet that is applied to string base type. Okay, so in this case it's not just a regular string, but is the string with 3 digits followed by hyphen followed by 2 uppercase ASCII characters. Okay, so those are the only ones that could be used with this SQU value. Okay, if the value of this SQU is not following this pattern, that is invalid XML document instance. Okay. Alright, so this is the third example of derived simple type. In this case, we are using enumeration. Okay, so in this case, we are defining US state simple type, and the base type is string, and we are using enumeration. Okay, so this US state has to be one of the values specified in this enumeration set of enumeration. So enumeration is a facet, okay, that restricts the value of base type of string to these values. Okay, so let's stop right here. It's 10:35, so let's have 15 minutes break, and we'll get back. In the meantime, if you guys have any questions, yeah, feel free to ask those questions. Okay, so let's just now we're going to move on to complex types. So complex type is defined using complex type element, and again, it typically contains element sub-elements and attribute sub-elements and element references. So let's see examples of this. So this is complex type example number 1. Here we are defining US address complex type. So here, unlike simple type, we have child element. Okay, and these child elements, we have 5 child elements. They are on the sequence, which means these elements should be present in this order. Okay, and it also have a sub-element called attribute. Okay, so it does have attribute called the country, and this is the attribute. Okay. Alright, so just repeat what I just said. It's defining US address complex type. It contains 5 sub-elements in sequence and 1 attribute sub-element. Okay, and US address definition contains only declarations involving simple types. So these are all simple types that are predefined in XML schema specification. This is a second example of complex type. So here we are defining purchase order type, complex type, and again it has 4 sub-elements and 1 attribute sub-element. Okay, now these sub-elements are using the complex type defined in previous slide. Okay, so this purchase order type, complex type, has ship to, build to, and comment and items. Okay, and build to and ship to is a type of US address. Okay, which we defined here. Okay, so you can build your complex type using other complex type. Okay, and this case is actually a simple type. Attribute cannot be complex type, so attribute always has to be a simple type like this. Okay, so again, repeating what I just said, its definition of purchase order type complex type contains type declarations referencing other complex type such as US address and items, and contains type declaration referencing simple type date. Okay. Okay, moving forward, elements versus attributes. So elements can reference both simple types or complex types. However, attribute can only reference a simple type, okay, because they cannot contain other sub-elements, okay. So here, this one cannot be complex type. It has to be always a simple type. Reference attribute. To use an existing element or attribute rather than declaring a brand new element or an attribute, you can use ref attribute. Now, this existing attribute that are being referenced must be global element. By global element, we mean it's an element that is declared on the root element. Okay, so let's see an example of ref. So here we have defined the schema, and here we define 3 global elements. Okay, so here this element is called the comment, and type is string, and here we are creating purchase order type, and we are actually referencing it. Okay, so it kind of simplifies your code, and it also enables reusability. Okay, so certainly you don't have to type these things. If you happen to have a long element definition like this, then you can just reference it. So it's simpler to write, as well as it enables reusability. And you could use this one in defining other, for example, complex type or derived type. Okay, just referencing it. Moving forward, occurrences. So occurrences of elements, we can actually specify with min occurs, max occurs. So min occurs is minimum occurrence, and max occurs obviously max occurrences. That is possible. Now you can use fixed attribute and default attribute, and there are minor differences. So when you use fixed with a value like this, if the element appears, okay, by the way, this element does not have to this is optional, meaning you don't have to have this fixed. Okay, now if you have this fixed, the value must be HANA. Okay, and if it is not, it's invalid. Or the value is set to HANA by the parser. On the other hand, the default, if the element appears, okay, element does not have to be appeared, okay, meaning it's an optional. The value is set to what is specified. So if I say default XYZ, then that's the value that will be used. However, if it does not appear, meaning if the element does not have does not appear, then the value is set to HANA by the parser. Okay, so there is a slight difference. Fixed, it has to be always HANA, otherwise it's invalid. Here, user specified value can be taken. Okay, so let's see examples of this. So this is a case that we are defining test1 element, test2 element, and with min occurs and max occurs. So in this case, this test1 element has to occur because it is 1 and max occurs 1, meaning it has to occur and it has to occur only once. Okay. In this case, it has to occur only once, and it is set with a fixed HANA. That means the value has to be HANA. Okay, if it appears, it has to appear, right? And then it has to be HANA. Otherwise invalid. The validation error will occur. This one, test3, can occur 2 or unbounded, meaning infinitely can happen. Okay. This one, 0 and 1, this is actually either occur or not occur. And fixed is HANA, that means value has to be HANA. Okay, so if it is specified, it has to be, the value has to be HANA. If the value is not HANA, if it is specified, then that's a validation error. Okay, so this is optional by using default. This is 0 or 2 occurrences, and default is HANA. And this one cannot occur. Max and mini is set to 0. Okay, so that means it cannot occur. If it occurs, that is a validation error. Okay, that is an occurrences of an attribute element. Okay, now we are talking about occurrences of attribute in this slide. Okay, so attributes can occur once or not at all. Okay, so you can use attribute. Okay, so required, that means it has to occur. Optional, meaning it can occur or not occur. Prohibited, it cannot occur. Okay, And attribute also could have attribute also could be specified with the fixed and default attribute. So this is an example of XML schema where we are defining this test1 attribute is required, meaning it has to occur in XML document instance. This is optional, meaning this test all, the test2 attribute, is optional. Okay, so it can occur or it does not have to occur. This one is optional but fixed 37, meaning if it occurs, the value has to be 37. If the value is not 37, that's invalid. Okay, XML document instance based on this XML schema. Okay, here this is optional and default is 37, so the value could be different. Okay, prohibited meaning it cannot occur. Alright, so this is an example of fixed attribute. So here we are defining US address, and it's a sequence of name, street, and things like that. And it also has an attribute, okay, sub-element, and the name of the sub-element is country. And use is optional, so it could happen or not happen. And the fixed is US. So if it happens, it should be US. Okay. So appearance of country attribute is optional, but the value must be US if it does appear. If it does not appear, the parser will create a country attribute with the value US. Okay, that's fixed. Default is again minor difference. So if it appears, the value does not have to be US. Okay, and that will be taken. Okay, so the attributes could be specified using enumeration. So simple type element with a base attribute, and the base attribute specifies the type. So let's see examples of how attribute could be specified. Okay, so here we are defining focus attribute, and default is Java. And now we can actually restrict it using restriction. And the base type is string, and the enumeration is either XML or Java. So this attribute can be either XML or Java. Okay, if it doesn't appear, then it's going to be set with the default value of Java. Okay. All right. So complete example. Now, one thing I want to actually make sure you guys understand is we are just dealing with the XML schema. Okay. Now we are not really dealing with XML document instance. Okay, so we are just looking at the XML schema. Okay, so this is a complete example. So here we are defining XML schema. Okay, so here this is the namespace, and prefix is XSD. So anything that starts with the XSD belongs to this XML schema namespace. Okay, and the elements that you are defining belongs to this target namespace. Okay. So the things that we are defining, like a book type, title, contents, and copyright. So these are the things that we are defining, right? So those things belongs to this target namespace. Okay. And here we have another namespace, and we are defining a prefix called Java XML. Okay. So anything that with Java XML belongs to this namespace. Okay. So here we define the complex type called the book type, and it contains 3 elements: title, contents, copyright in sequence. And these elements are type of string and type of contents type defined in another namespace, and this one is type of string, XSD string. And here we're defining complex type. Okay, so we're gonna learn later on anonymous complex type, meaning this guy's it does have a complex type. Oh yeah, this is explicit, the complex types. As you can see, we are defining content type of complex type here, and then we actually include these guys. So it's a sequence of this and this. Okay, and inside we are defining another complex type of this, and then inside the complex type we have a sequence of this, which includes heading, topic, and again inside we have another complex type, which is an attribute here. And here we are defining attribute who's actually limited with enumeration, which are restricted with enumeration. Alright, so we are going to do our first lab exercise, Okay, so here we are going to actually build simple XML schema using Eclipse. Okay, so let's take a look at the lab documentation. So you download a zip file, and once you unzip the file, it will create WS XML schema directory. Underneath you have index.html document. That's the documentation we are looking at. Okay. Oops. So exercise 1 is creating a very simple XML schema. So the XML schema that we are going to create using Eclipse built-in XML editor is basically we are trying to create this XML schema. Okay, so here we define a complex type called simple process, which contains an element type of string and in sequence. Yeah, so this probably doesn't that much make sense, having this a single element inside the sequence. Okay, but it's still valid. And then we define then we declare an element called the type A, whose type is something we define right here. Okay. All right. So here, start the Eclipse IDE if you have not done so yet. Okay. And then we are going to create a brand new so basically, you can take a look at example here. File, new, and example. And then editing and validating XML files. Okay, so we are creating the XML. We are creating a project name called the XML examples. Okay, and then we are going to create XML schema file. Okay, so we are going to say file new, and go to other, and then expand XML, and then we are going to see XML schema file, and then click next. And you're going to name that XML schema as my own, okay, on the XML examples directory, okay. And we're going to name it as a synchronous sample.xsd. So this is the XML schema file that we are creating, okay. And so it will have a synchronous simple XSD file. It doesn't contain anything, but it's a skeleton of schema element here, okay. All right. Now you can actually build the XML schema using design mode. Okay. So here you can actually click the design here to see the design mode. Okay. And then you can actually do zoom out and zoom in. Okay. That's possible. So now the first thing we are going to do is we're going to create the complex type. So basically what you're trying to create first is complex type of this guy. Okay, so we're going to name it as simple process, and then we have to add element, sub-element. Okay, so that's what we're going to do. Okay, all right, so that is actually step 3. So right here you can say the add complex type. Okay, so we are basically defining new types. Okay, so add complex type, we are going to name it as simple process complex type. Okay. And once we have a simple process complex type, then we are going to add a child element. Okay, so we are going to add child element by clicking add element. Okay, and we are going to name it as param A. Okay, so you can just type your name, param A. Okay, right now it's actually set to string. Okay, so if you see the source mode, this is what you are going to see. So we created a simple process, and as a default, it will actually add any child element on the sequence. Okay, and we name it as a param A, and type is string. Okay, so and then we are going to add global element. So we are declaring an element which uses the type that we just defined. So we go to element here, and then you say add element. Okay, and this element, instead of string type, we want to use the type that we just defined, right? So instead of string, you're going to actually set type, and you're going to browse the types that have been defined so far. And we have defined only one type, which is a simple process, right? So you're going to select the simple process, and then this type A element will using the simple process type that we define here. Okay, so if you take a look at the source, this is again what you are going to define. This is what you are going to actually create. Okay, all right. So that is exercise 1. I'm going to give you guys about 12 minutes to finish this exercise. Now the next is list type. So list type is a simple type, and is comprised of sequences of atomic simple values. So you're going to say list and item type equal myInteger, okay? And user define, so it's basically user defined list type, and it's going to derive from atomic types, and we're going to see examples of that. And the facets you can use with the list type is length, minimum length, and max length, and enumeration. Okay, so let's see examples of this. So this is the schema you are defining. In this case, you are using list type, and then this is the usage of it. Okay, so this is the usage of this schema type in XML document instance. Okay, so in this case, in the schema, what we are defining is myInteger simple type, okay, and myInteger is between the range of 10,000 and 9999. So this is something that we have defined as myInteger. Now we are defining list of myInt type. Okay, so this is a list type. Inside is going to say list, and item type is myInteger. Okay, so when you're using list of myInt type in XML document instance like this, you can have a list of the integers of myInteger. So as long as these numbers are in between these 10,000 and 9999, you can have this is a valid. The usage of list of myInt type. Okay, if you happen to have a number that is beyond the range of these two, okay, then that becomes invalid XML document instance, so validation will fail. Okay, so this is an example of list type. Okay. Okay, so this is the case that we are deriving another type from a list type. Okay, so this is the list type that we just, so this is US state. In this case, we have enumeration. Okay, so US state has to be one of those 50 US state, 2 characters. And then we have a list type of US state list, which is a list of US state. Okay, so list type should be the list of these, two characters. Okay, now we are defining another derived type from the list type. So here we're defining 6 US state, and we are restricting this US state list type with the length. Okay, so length in this case is a facet. So we are restricting this US state list type with a value of 6 facet. Okay, right? Now we can actually define an element. We can declare an element called the 6 state with the type of these 6 US states. Okay, so this is XML schema. Now let's take a look at XML document instance that is using this type defined in this XML schema. Okay, so example, so this is the derived type from list type. So in order to define a list of exactly 6 state, we name it as a 6 US state. We first define enumeration of US state, then we create a new list type called the US state list, and then we derive 6 US state by restricting US state list with only 6 items. So usage of the type in XML document instance is going to be something like this: 6 state, and you can have only 6 US state. If you have a less than 6 or greater than 6, that is invalid XML document instance against the XML schema that we just defined in previous slide. Okay. All right, so that is a list type. Now let's move on to union type. Union type is also a simple type, and it enables an element or attribute value to be the union of one or more instances of one type drawn from the union of multiple atomic and list types. Okay, and you can use facets of pattern and enumeration. So let's see examples of this. Okay, so this is the XML schema. So here we are defining zip union, simple type, and it's a union of this type and this type. So it could be, it is a union of US state type, which is defined right here, and a list of my int type, which is defined right here. So union of this and this. Okay, and then we are then creating locations complex type using this zip union simple type we just defined, which is a union type. Okay, so if you see examples of this, if you are taking a look at the location, then it should be examples of this is something like this. So here we could, the zips, basically we are actually using this zip element, right? Okay, the zips element could be a type of zip union. Okay, so what it means is that it could be anything. It could be AK, so which is actually from US state type, or the zip code, which is coming from this type. Okay, all right. Okay, so that is a union type example. So this is XML document instance, which is valid against this schema that we defined. Okay, all right. So here we define the complex type called locations, and then we are using the type to define an element of some locations, right? So if you see XML document instance, we use some elements element, okay, and inside it could be the union of zips, the element, okay. Okay, moving forward. Now, explicit type versus implicit type. So explicit type is the one in which a name is given to the type. Okay? And then element that uses a type is generally defined in a different location of the schema, and is object-oriented in that same explicit type can be used in multiple places. Okay? Implicit type, however, is called nameless type or anonymous type, and it is a type that doesn't have a name. Okay, and you typically use implicit type only when type is not used by multiple elements, meaning it's used only by one single element. Okay, so let's say an example of explicit type. So the examples we have seen so far are all explicit type. Okay, so here we define a type called a zip union. So this type has a name, zip union, and then we can use this zip union in multiple locations. Here, here, and here. So it promotes reusability. Okay, so this is the explicit type definition. Now, examples of implicit type is that when the type is used only by a single element, then it doesn't have to be explicitly specified. So this is an example of implicit type. Okay, so here we have we have this example. We have a combination of explicit complex type, implicit complex type, which is sometimes called the anonymous type or nameless type, and then we have an explicit simple type, implicit simple type. Okay, so the first one. Okay, this guy, complex type with a name. So it has a name. So this is explicit type. Okay, so this complex type has a name called items. Okay, and then we can use this complex type someplace else. Okay, now we have a sequence of elements. So we have sequence of this element. In this case, we have a single element, right? Okay, internally it has a single element called the item. Okay, and now you can see this complex type is defined internally. So this is an example of implicit type. You can see this complex type doesn't have a name because it's used just once in this element. Okay, so this is an example of implicit type or nameless type. And inside it has a sequence of elements, and one of the elements is called the quality. And here it defines internally, it's using simple type. Again, this is example of nameless type, nameless simple type in this case, because it's used only once inside this element. Okay? And this is the example of explicit type, because explicit simple type because it has a name. Okay, and this simple type could be SQ is going to be used in other places, multiple places. Okay, this complex type can be used only once in this. Okay, because it doesn't have a name. This guy, and this simple type could be used only once here. Okay. Okay, moving forward, choices and groups. So the choice, only one of his children to appear in an instance. So if you have if you want to actually have only one of his children to appear in an instance, XML document instance, you can use choice. Group is a group of elements. So if the sequence is an example of group. Okay, if you want to have them in sequence, then you're going to use sequence. If you're using all means appear 0 or 1s and in any order. Okay. All right. So this is an example of choice. So here we're defining a purchase order complex type, and is a sequence of this guy. Okay, and so the choice here. The first is the sequence of these two guys, this or this, okay? And this one has to be present all the time. However, this one is actually one of these two. It's a choice, either this guy or this guy, okay? So here, this one either single US address or it's going to be a group of this, okay? So we're going to actually see this one in the following slide, okay? Now this is a group, so you can actually have the name of ship and bill, and this is the sequence. So ship to and bill to, and then this is US address complex type. Okay, so basically what we want to do is, we want to either have, basically what we want is that the information that we are going to have is either both ship and bill. So this is the case of this guy. I want to have either shipped and billed to, or just the address. Okay, in that case, US address. And here this guy is using US address as a type. Okay, all right. This is example all. So all means it happens. It happens appears 0 or 1s in any order. Okay. So in this case, this order, the order of this one could be anything. Okay, unlike sequence. Okay, so this case we have a ship to, build to, and the comment and items, and then it also have attribute sub-element. Okay. Okay, so schema namespaces. Again, this is a review of what we covered in the namespace presentation. So I'm going to actually go back to namespace presentation and look into these concepts one more time as I promised. Okay, so this is just the summary. So as I said before, there are two different types of namespaces. One is called the target namespace. The other one is called the source namespaces. Okay, so the namespaces that you are seeing in XML document instance, mostly it is the source namespaces. Okay, so namespace external to XML schema document. Okay, and the target namespace is the namespace that is going to be assigned to the schema that you are creating. Okay, so when you're creating XML schema, you have to have one target namespace, because you are defining elements and attributes, right? So the names, meaning elements and attributes that you are defining in the schema, belongs to this target namespace. So in XML document instance, it's going to use this target namespace as a source namespace. Okay, so it is a namespace a document instance uses to access the types it declares. Okay, all right. So each schema has one target namespace and possibly many source namespaces. Okay. All right. So we're gonna, before we do exercise 2, I'm gonna actually go back to the namespace presentation one more time, and then we'll actually go over this concept one more time. Schema namespaces. So as I said before, target namespace is the namespace for the XML schema document itself, meaning in your XML schema, you have to actually define the target namespace, because that is the namespace that has to be used as a source namespace in other XML documents. It could be XML document instances or other schemas that are actually using this, your schema as a source namespace. Okay, and source namespace is the namespace external to XML schema document. Okay, so let's say an example. Okay, so just one more time. Target namespace, it is a namespace that is going to be assigned to the schema that you are creating, meaning any elements or attributes that you are defining in the schema belong to this target namespace. Okay, so it is a namespace, a document instance, meaning XML document instance uses to access the types it declares, meaning elements and attributes. Alright, so each schema has a single target namespace, but it could have a multiple source namespaces. Alright, so this is an example we have seen before. So this is again XML schema document. Okay, so here it defines target namespace. Okay, called samplestore.com account. Okay, so any elements or attributes you are defining here belong to this target namespace. Okay, so the things we are defining is invoice number, product, and product code. So these blue colored elements that you are defining in this schema belongs to this namespace. So anybody's using these three elements, whether that is an XML document instance or another XML schema, should specify this one as source namespace. Okay, now these two guys are examples of source namespaces, meaning when you are using, you're basically using elements defined in these source namespaces. Okay, so one of those source namespaces is in fact the XML schema itself. So anything that I'm using, like element or simple type restriction pattern, those all belong to this XML schema. Okay, so that's the reason they have to prefix with the XSD like this. Okay, same thing with the positive integer XSD. Alright, now what about this? Okay, this is another source namespace, but happen to be the same as target namespace. The reason is because you are creating product element using another type in the same XML schema. Okay, so you are actually user. You are also, when you are defining product element, you are using another type. Okay, so that's the reason you have to specify your own schema as the source namespace so that you can use it. Okay, so this is a repeat of what I just explained. The target namespace name is this blue colored namespace, which contains these three elements in its namespaces. Okay, and these red colored elements are from this XML schema namespace. Okay, the target namespace also happens to be one of the source namespaces because the name product code is used in defining other names. So if you are not defining, if you actually skip this line, then you don't have to define the source namespace because you're not using it. Okay, now schema, importing a schema with a schema location. So when you're using the source namespaces, what it means is that any elements that you're using in this schema has to be validated against the XML schema document of these namespaces. Okay, so what that means is that there has to be XML schema document reflecting the validation, reflecting the syntax of any elements that you're using in this namespace, But what is the XML schema document for these two source namespaces? Okay, the reason you don't have to specify is because this particular namespace is well-known namespace. Okay, every parser is built with where to get these things, so you don't have to specify schema location of this well-known XML schema namespace. This one you don't have to specify schema location because this is the same as this namespace, so it knows where to go. Okay, so it knows where to get this product code. Okay, now however, so this is what I just explained. Schema file uses the several source namespaces, but how does it know where to get the schema files of the source namespaces? In this particular example we just seen, you don't see schema location because one is well-known schema namespace and the other one is a source namespace, and target namespace is the same. Okay, however, if you're using an elements defined in this namespace, there has to be XML schema document reflecting the validation, reflecting the syntax of those elements. That is supposed to be provided using schema location. Okay, so you have to use import namespace and the schema location. So this is the XSD file that defines all the elements, okay, that belongs to this namespace. Okay, so so if you take a look at this XSD file here, you are going to see this is used as this is defined as a target namespace in this XML schema file. Okay, all right. So because this is not well known and this is not the same as the target namespace, you have to provide the schema location, meaning the location where XSD file can be downloaded. See, so this one has to be a valid URL. You know, the parser will actually go to this URL and try to download this alpha.xsd file. Okay, and to compare the syntax, I mean, then we'll actually use the syntax of that, the syntax defined in the XSD to validate this XML document. Okay, in this case, it's a schema file. Okay. All right, so that is the explanation. Hopefully that kind of clarifies the concept of namespaces. All right. Okay. All right, so let's go to exercise 2. So exercise 2 is mainly to take a look at example XSD schema files. Okay. So let's take a look at the. It comes with a couple of the XSD file. So go to phone banking XSD file, or you can actually go to other directory and take a look at the XSD file. So if you take a look at the phone banking XSD file, it's relatively straightforward. Okay, so here we are declaring account info whose type is account type. So account type should be defined somewhere. So account type is defined as a complex type. Okay, and it contains two attributes, name and account ID. Okay, and then we have a payee element whose type is payee. So we are going to see complex type defined with payee. Okay, and then we have element type of paylist whose type is paylist. So that is defined right here. So it's relatively simple type, and we have a build to. Which is actually, so here we actually also have a build to whose type is a bill info type, which is a complex type, and it's a sequence of this one element, and then it has a 3 attribute: amount, account type, and date. Okay, and now if you take a look at the schema, this is the default namespace. This is a default namespace, so that's the reason you don't have to specify XSD prefix here, because this is a default namespace, right? And then because this is XML schema file, it has to define a target namespace. Okay, so this is a target namespace. Okay, and then this is so this is another example where the source names, the target namespace is also used the source namespace, because again in this example it's actually defining another element using its own element. So we have to define target namespace, so source namespace. So whenever you actually see TNS here. Let's see if so this TNS, you can see this element is using payee type using TNS. Okay, so this is an example where element payee is declared using its own type. Okay, all right, so you can display in design mode. So these are all elements and these are the types. Okay, and you can see these elements using the types defined here. So account info is using account type. Bill info is using bill info type, and completion code is completion code type, and things like that. Okay, and you can actually validate the XSD. Okay, this is actually validating XML schema itself. Okay, so it's validating whether XML schema is following XML the guidance in the XML document. Okay, and you can also take a look at another XML schema, in this case catalog. Okay, so you can take a look at this catalog and see whether it makes sense to you. I mean, it's pretty straightforward. Once you know the concept of it, there is nothing much to it. Okay. All right, that's validation. And so this is the case that we actually have the XML document instance Okay, so this is the XML document instance. So the XML document instance has to be validated against the catalog XSD. Okay, so catalog XSD defines the syntax of any document instances. So catalog.xml is document, one of the document instances. Okay, and you can validate it. When you say validate XML document instance, it's going to use XML schema to see whether the XML document instance follows the syntax defined in XML schema. Okay. All right, so I'm going to give you guys 10 minutes to finish the exercise 2. All right.